In this lesson, we're going to look at evaluating function notation. All right, example 1, how do I evaluate a function from an equation? So first of all, remember yesterday we talked about writing equations as functions. And we said that this would be read as the f of x is equal to 5x plus 3, where the f of x is our output value and the x is our input value. We also said yesterday that whatever letter we have inside of here has to match up with that letter that you have in your expression part of your equation. So we're going to go ahead and we're going to evaluate these functions. For number 1, I have the f of x is equal to 3x plus 4. And for letter A, it says the f of 2. Now what this means is that when you see this number in the parentheses, this means that this right here, that's our independent variable. It's like saying x is equal to 2. So we're going to take this 2 and we're going to plug it into our equation then where we see the x. So you will have the f of x is equal to 3, and we're saying x is 2 plus 4. And all we're doing now is we are simplifying. So the f of x is equal to, well, 3 times 2 is 6, and 6 plus 4 is equal to 10. And so the f of x, or the output, is equal to 10. So now if I were to evaluate the f of negative 4, again, what we're saying is what is in the parentheses is going to be our x. So we're saying that x is equal to negative 4. And so we're going to go then up into this function that we have up top here, and we're going to plug in the negative 4 for x. So we're going to have the f of x is equal to 3 times, well, we're saying x is negative 4, and then plus 4. So we'll have negative 12 plus 4, so the f of x is equal to negative 8. All right, for question number 2, we've got the g of x is equal to x squared plus 5. So remember, the number that is in the parentheses is our input value. That's the number we're going to plug in for our x. So this right here is being plugged in as our input. So we're going to then, let's write out our equation. We're going to have the g of x is equal to negative 3. Now remember, if you've got a variable that's assigned to a negative number and you've got it squared, it does have to have the parentheses around it. So I've got negative 3 squared plus 5. So now we're going to simplify. The g of x is equal to, so remember, when you've got the negative 3 in the parentheses, it's like saying negative 3 times negative 3. Well, that's going to give us a positive 9. And so we'll have 9 plus 5 is going to be equal to 14. So when the input is negative 3, the output is 14. For our last one now, we're going to plug in the negative 4 in for our x. So we've got the g of x is equal to, we're going to plug in our negative 4 squared, and then plus 5. So the g of x is equal to, well, negative 4 squared is negative 4 times negative 4, and that gives us 16, and then 16 plus 5 gives us 21. All right, so for our next example, we have 3 different functions listed here. I've got the f of x is equal to 2x plus 1. We've got the g of x is equal to x squared plus 3, and the h of x is equal to the absolute value of x plus 2. So we need to make sure that when we're plugging in for our function, we need to make sure that we're plugging it into the correct function. So if I were to then take this g, I need to be plugging my x in for this function right here. So we're saying that x is equal to, our independent variable is equal to negative 2, and we're plugging it into the function that's got the g of x. So I'm going to have the g of x is equal to x squared. So again, remember, you've got to have the parentheses here, and then plus 3. So we just took that equation right here, or the function, and we're plugging in our x into that x value. And then we're just going to simplify. So I've got the g of x is equal to, well, negative 2 times negative 2 is 4, and 4 plus 3 is 7. So our answer, the g of x, or the output, is equal to 7. All right, for letter B then, I've got the f of 3, and so I have to use this function right over here that is got our f, and so we're going to plug in this 3 where we see the x here. So I'm going to write down the function. I've got the f of x is equal to 2, and the value that's in that parentheses is what our input value is. So I'm going to take 2 times 3 plus 1. And then I'm just going to simplify it. We've got the f of x is equal to 2 times 3 is 6, and 6 plus 1 is equal to 7. And you're all done. And then for our last one on this row, we have the h of negative 5. So I'm going to plug in where I see the h of x, I'm going to plug in negative 5 where I see the x. So we have the h of x is equal to, well, we have the absolute value of negative 5 plus 2. And so we have the h of x is equal to, well, negative 5 plus 2, so you're going to have the absolute value of negative 3. And then remember that absolute value is the distance a number is away from 0, and absolute value is always going to be positive. So the f of x then is going to be equal to positive 3. All right, so for letter D then, we've got the f of negative 3, so we're looking for the function that has the f, and we're going to plug that value then in for our x. So I've got the f of x is equal to 2 times negative 3 plus 1. And now we're just simplifying it. So f of x is equal to, so 2 times negative 3 is negative 6, plus 1 will give us a negative 5. So the f of x is equal to negative 5. All right, so we have the h of negative 1. So we're going to come over here, we're going to plug this in right here. And so we have the h of x is equal to the absolute value of negative 1 plus 2. All right, so the h of x is equal to, now remember, and I didn't mention that before, but if you're looking for the absolute value, you do have to evaluate what is inside the absolute value first before taking the absolute value. So negative 1 plus 2 is equal to 1. And so the absolute value of 1, remember, absolute value is always going to be positive, so it's going to be equal to 1. And then for our last one that we have here, we're saying that g of 1, so again, x is equal to 1. So we're going to plug it right in there. We've got g of x is equal to 1 squared plus 3. G of x is equal to 1 squared is 1 plus 3, and that's going to be equal to then 4. All right, example number 2, how do I evaluate a function from a table and a graph? I believe on your notes packet, I had removed one of the graphs, so it might look a little bit different, but this question number 1 and number 2 are on your notes packet. They just might be in a different order there. So when we have the f of 2 is equal to, and we have got a table, remember, what we're saying is that that number inside that parentheses is the input, it's the x. We're saying that x is equal to 2. So if x is equal to 2, we're going to come over and look at our table, and we're going to find that when x is equal to 2, that the f of x is equal to 10. So we're just going to write down the f of x is equal to 10. So again, we've got the f of 6. We're saying that x is equal to 6. So x is equal to 6. So we're going to come over here and find on our table where we have an x at 6. And we're going to say what the output is then. It's kind of like when we would say y is equal to, we're just replacing that f of x, or the y with the f of x. So we're saying that the f of x is equal to then 61. Right now might be a good time for you to pause the video and to see if you can do the next two, and then we'll resume and I will go over those two. All right, so If I've got the f of 9, we're saying that x is equal to 9. And so I need to know what the f of x is. So that when the input is 9, the output, or the f of x, is equal to 83. And then our last one here, I've got the f of 5. It's like saying x is equal to 5. Well, when the x is equal to 5, or when the input is equal to 5, the output, or the f of x, is equal to 94. All right, so now we're going to evaluate the functions by using a graph. So if I have the f of negative 3, remember that's like saying our input, our x, is equal to negative 3. So what we're going to do is we're going to come up here on our graph, and we're going to come to the negative 3. So I'm going to start here. I'm going to go over 3, 1, 2, 3. And then I'm going to look, once I've gone x is equal to negative 3, I'm going to go up to where it's going to cross the line. And so notice at that point right here it's at negative 3, 2. Basically, it's like saying x and y. So negative 3, 2, except for we're using function notation. So we're going to say that the f of x, when x is equal to negative 3, the y, or the f of x, is equal to 2. So again, for letter B, we're saying that the input, or the x, is equal to 1. So x is equal to 1. You're going to walk over 1. So let's change colors here. Let's use a yellow. So we're going to walk over to the 1. And now I'm going to walk up, and I'm going to where it's going to then cross on the y-axis. So it's crossing, when I walk over 1, it's crossing at the 2. So the f of 1, or the f of x, then is equal to 2. All right, for letter C, we have f of 0. So that's like saying x is equal to 0. It's like saying when x is 0, what is y? That's exactly what we're doing. So let's take a look here. I'm not going to walk any, and I'm going to go up. So we're going to stay on the y-axis, and we're going to go up, and we're going to see then where it's crossing it. So when x is 0, it's crossing it on the point 0, and then we went up 1, 2, 3, 4, 5. So when x is 0, the y, or the f of x, is equal to 5. And now for our last one, we have the f of 2. So we're saying that when the input, or the x, is equal to 2, we're going to find where it then crosses. So we're going to walk over 2. Now notice when I walk over to the 2, I can't go up. It looks like I'm going down. So I'm going down on my line, and it looks like it's crossing then at then the negative 3. So the point there then is I walked over 2, and then had to find where it's going to cross on the line at the 2, and it looks like it's crossing at 2, negative 3. So the f of x is equal to negative 3. So in this lesson, we took a look at how to evaluate function notation when you have it in an equation, when you have it in a table, and when you have it in a graph.